Okay, so now let's take a look at the Cournot Duopoly. And what I'm trying to show you is basically summarized here. And I will derive everything step by step. However, I'll make it a little bit more complicated than what you see here by not assuming that the marginal cost is zero, but I'll keep it a variable. So, but once you understand the slightly more complex way that I will illustrate now, looking at this slide should be a piece of cake. Okay, so now let's begin. So how do we start with a duopoly, a Cournot duopoly? Okay, so we have a Cournot duopoly. So that means we have two players and they need to react in response to what the other player is doing. And we start by acknowledging that we have a demand function, which we typically write as A minus B times Q. But now Q is composed of the supply of firm 1 and firm 2. So we can write A minus B times Q1 plus Q2. So we have two players, Q1 and Q2. So now let's take a look at each player's profit maximizing condition. So let's begin with duopolist 1. And the duopolist 1 has the total revenue function 1, which is now A, that's the price here, minus BQ1. And I already multiplied through, so minus BQ minus BQ2 times Q1. Well, for duopolist 2, it would be similar. So for duopolist 2, we would write total revenue of duopolist 2 is A minus BQ1 minus Q2. But now we multiplied, I forgot the B, but now I would multiply times Q2. Okay, so then we take a look at the marginal revenue. So the marginal revenue is the first derivative of the total revenue. So we will do marginal revenue with respect to Q1. And then we get, maybe I should have first multiplied through. So that would be A times Q1 A times Q1 minus BQ1 squared minus BQ2 Q1. And here likewise we would multiply through A Q2 minus BQ1 Q2 minus BQ2 squared. Okay, but now we can take the marginal revenue. So the marginal revenue is the change in total revenue here with respect to Q1. And then we get A minus 2BQ1 minus BQ2. And here the marginal revenue would be the change in total revenue with respect to Q2. And we get A minus, I start with this one, minus 2BQ2 minus BQ1. Okay, so you should see the symmetry. And now we maximize profit by equating marginal revenue equals marginal cost. and I just call marginal cost M. And you see on this slide, I assume that the marginal cost is 0, and I didn't explicitly consider it, but I add it here. So marginal revenues equals marginal cost. So now we have to solve A minus 2B Q1 minus B Q2 equals M. So now we have to solve for Q1. So we can rearrange terms and we find the optimum Q1. Okay, put that on the other side. And then I say A minus M minus BQ2. And now I divide by 2B. And then I get A minus M over 2B. And I also divide BQ2 over 2B, so then the B cancels out. And I get minus 1/2 times Q2. That is what we call the response function for Dupoly list 1. And again, here we would do the same thing. Let's do it again. So now we have to equate A minus 2B Q2 minus BQ1 equals M. So we assume that they have the same marginal cost function. And then you can already see the symmetry. What we should get is Q2 star is A minus M over 2B minus 1/2 Q1. So now you see that each duopolist needs to respond to the other monopolist by finding the optimum quantity. Okay, so now let's find the equilibrium. So what's the equilibrium? So the equilibrium is a situation in which no firm has an incentive to change their optimum quantity in response to what the other company chooses. So let's illustrate it graphically. So we can display each firm's response function. So here with Q2, here Q1. And let's make firm 1, let's make that red. So if we take a look at this function here, so the intercept is Q1. So there's an intercept at A minus M over 2B. So let's put that here, A minus M over 2B. Okay, the slope is negative 1/2. So it's maybe something like this. Maybe that's 1/2. Well, that means that the intersection here is twice A minus M over 2B, which is A minus M over B. Okay, so now let's do the response function for the other one, and let's make that in blue. Okay, so but now here we have Q2 to the left side of the equation. So what we can do is to match this equation, this graph, we would have to rearrange the terms and put Q1 to the left side of the equation. Or I tilt my head a little bit like this, now you can see it, but I look at the graph like this, and then I know, oh, the intercept is actually here, at A minus M 2B, so it's half here. It's A minus M over 2B. And then the slope is 1/2, so it must go here at A minus MB. We could also have rearranged this one, and if we had rearranged this equation, then we would get, oh wow, then you would get A minus M over B minus 2 times Q2. That's what we would have gotten. But I leave that for you. So what's more interesting is now finding that point of equilibrium. So where's the equilibrium? So the equilibrium is now this point where firm 1 chooses a quantity to which firm 2 responds with a quantity that doesn't cause a change anymore in firm 1's quantity, and so on. So we need to find that point, and that is, we need to equate the two equations, A minus M over 2B minus 1/2 Q2. That is the same as the blue one, which is, now we cannot look at this one, we need to look at the graph, which is A minus M over B minus 2 times Q2. Okay, now we solve for Q2, and then we put the two Q2's on each side, and I am left here with 3 over 2 Q2, and then I subtract half an A minus MB from an entire A minus MB. So this term becomes now A minus M over 2B, because I subtract half one, and then I multiply both sides by 2 over 3, and then I get Q2 star. The 2 cancels out, so A minus M over 3. And of course, because it is symmetric, we know this is equal to Q1 star. And if you want to, you can take A minus M3 for Q2 and plug it in here, and then you get also A minus M over 3. But I just skip that here now, because I think it's obvious from the graph. But if you want to double check, plug in A minus M over 3 into this equation for Q2, and you will get the same result. So those are the optimum quantities, and so now we can also calculate the equilibrium price. So what's the equilibrium price? Okay, so we know that the price is given by A minus B Q1 plus Q2. So now we have A minus, I multiply again, so B Q1, oh I forgot here the B. You see 2, but then over 3, the B doesn't disappear, it disappears now. So A minus B times Q1, which is A minus M over 3B. And of course now the B cancels out. Minus B times Q2, and that is also A minus M over 3B, but then again the B cancels out. Okay, so now let's maybe multiply through. So we have A minus A third that's not a good A minus, so we have here minus times minus, so we have plus M over 3 minus A over 3 minus times minus plus M over 3. So then it follows that the optimum price, or the equilibrium price, so an optimum is a duopoly, the optimum would be perfect competition. So we have A minus A third minus another A third. That leaves us with 1/3 A minus 1/3 A. But then we have plus M3 and another M3 plus 2M3. So that's the equilibrium price. Okay, and so let's double check with what I have here. So we have the optimum quantity A over 3B, yeah, that's correct, and the price is A over 3, and you see we have A over 3, but we still have the fixed cost, the marginal cost that are equal to 0. If I inserted here 0 for M, I would also get the same result. And last but not least, we have still calculated here the profit, so for each firm. So let's still do that. And the profit is total revenue, which is the price. Okay, I hope it will fit in here. So it's the price, which is A over 3 plus 2M over 3. So let's just put a common denominator. Okay. Times the optimum quantity, which is A minus M over 3B, so that is the total revenue. And if we subtract total cost, so we don't know what the fixed costs are, so assume that the fixed costs are 0, but then we would say minus the marginal cost times the quantity. That will be then total variable cost, so minus M times the optimum quantity, which is A minus M over 3B. So the first term is total revenue, and then the second one is total cost. Okay, so now let's first multiply the first term, then we get A plus 2m A minus m over 9b minus m times A minus m over 3b. So in the previous example we assumed that m equals 0. So if n equals 0, so let's calculate the profit when m equals 0. Okay, so now we are here, a plus 2m, that's 0, a minus m, so we get a squared over 9b, and if that m is 0, everything becomes 0. So if the profit is indeed 0, we get a squared over 9b, which is also what we see here. But if the marginal costs were not 0, we would get something else. Okay, but you see, this is how we calculate the equilibrium in a Cournot duopoly, and you can see that each optimum quantity, each firm's optimum quantity is a function of the other firm's quantity. So yeah, let's just stop here and then continue the next video with the Stackelberg-Lido follower model, and then also a third version, Bertrand competition, and then we compare the various welfare implications of each monopoly. But before we get to the welfare implications, let's first introduce the Stackelberg-Lido follower model next.